I'm recording this now. We're doing 3.4 zeros of polynomial functions today. We're just diving into where are the answers? Where does our function cross the x-axis? Where are the intersections? So let's pay attention to still this here. On Wednesday, we will do the review, and you'll have Wednesday, Thursday, and Friday to take your test. It's due March 5th. That's Friday at midnight. Same rules as last time. You can see when your homework deadline's out. All of this homework will deadline out on midnight Thursday night. And then Friday morning, I'll take your hundreds off of there, and I'll reopen the review. For those of you who haven't taken the test on Friday, you'll still be able to get into the review on Friday. Then we'll have a week longer. Next week we'll come to class, and then we'll have spring break. You won't be doing anything over spring break for this class. This will be what we'll do Monday and Wednesday, and then we'll be done for almost 2 weeks. Okay, let's look at zeros. I'm going to start where they, let me focus this. I'm going to start where they end, because I think that makes a little more sense to see what you're doing, and I think that helps the last few problems. So the last couple of problems are going to ask you, what is the smallest degree possible? Smallest degree of the equation possible. So they'll give you a picture like that. There's a parabola, upside down parabola, and the degree, remember, is going to be the number of times that it crosses the x-axis. That's the number of answers. That's the number of x-intercepts. That's the number of degree, all of that. It's all related. So we see this one crosses once, twice. So the smallest degree possible would be x squared there. And you actually know that that's a parabola, so it's an x squared. It has a minus in front of it, but they're going, on these last couple of problems on this section, they're only going to ask you for the smallest degree possible. So your answer is a 2. How many times does it cross the x-axis? That's what they're asking you. So let me do it in another pen color. If they give you something like that and ask you for the smallest degree possible, again, you're just looking at the number of times it crosses the x-axis. 1, 2, 3. So that would be a third degree polynomial, because the exponent matches the number of possible answers. And let's look at one more. Let's say it does something like, well, it'd help if I does something like squiggly, squiggly, and then, kind of messed that up. Should be curvy there. Okay, the point is the squiggly. So we've got 1 time that it crosses cleanly, 2 times that it crosses cleanly. But remember, a squiggly is going to be 3 times. So 1, 2, 3, 4, 5. So this would be a 5th degree polynomial. That's the possibility of 5 answers. 1, this would be x cubed right in there, minimum. It could be x to the 5th, x to the 4th, but more than that. Remember, this is asking for the smallest degree. So it crosses twice there, it's a 2nd degree. Crosses 1, 2, 3, it's a 3rd degree. Crosses 1, 2, but then this is going to be at least 3 when it's a squiggly. So the smallest would be 1, 2, 3, 4, 5, 5th degree. Okay, that's where they end up, and I wanted to start with it because I want you to think about that these answers that we're getting are where does it cross the x-axis. Okay, so that first concept here that I want to be sure that you know is that the degree n, they'll call it n, that exponent is n, that tells you that you're going to have n roots. That's the number of possible solutions. Number of possible solutions. And, you know, I've talked about that and talked about that way before we started with this, that when we get 2 answers, I'll show you, oh, look, we had an x squared. The exponent always tells you the number of solutions you're going to have. Okay, next what I want to cover, second thing I want to cover is if a rational solution exists, if there is a place that it crosses the x-axis. So if a rational solution exists, like if you're given this great big equation and you're trying to figure out, does it cross the x-axis? Where does it cross the x-axis? That's what we're going to be looking at. Where are our zeros? Where does it cross the x-axis? So if it exists, if a rational solution exists, it will be in the form P over Q, where P is the factors of the constant, and we're just about to play this game, so if you're like, what? Don't worry. And Q represents the factors of the leading coefficient. Leading coefficient, we've looked at that term before, but we're looking at it again. So it'll be in the form of a fraction, all the zeros that are possible. For instance, let's look at 1, 2, 3, 4, 5 times. The first time, f of x equals 5x to the fourth plus 22x to the third plus 24x squared plus 26x minus 10. Okay, there's our equation. We can see we're going to have 4 zeros there, but where are they going to be? Where are they going to cross the x-axis? We could, we could go forever doing synthetic division on every number we can think of, trying to come up with something that will zero out in the remainder. Looking and looking and looking. But here's the way to narrow that down. If a rational solution exists, if it does cross the x-axis, and why I'm saying that is, let's look at this particular one. You know that we're going to have 4 answers, but none of them might cross the x-axis. They could be floating around up here. They could be doing that. This will never have a rational solution. It's never going to drop down to the x-axis. But if it does, if these little crossings, if these little up and down action, if it does exist to cross the x-axis, then it will be in the form of P over Q. Okay, let's look at what that means. P is the factors of the constant. So P will be the factors of this number back here, 10. We don't have to worry about the fact that he is negative. So what are the factors of 10? 1 will go into 10, 2 will go into 10, 5 will go into 10, and 10 will go into 10. We're done. Those are the factors of 10. Now, later. The factors of the leading coefficient will create the denominator for these possible answers. So the factors of the leading coefficient, well, what is the leading coefficient? It's a 5. We don't care about any of this in here. We don't care about any of that in there. Bozo the Clown could be residing in there, and you won't be looking at it pretty soon. You're only looking at P and Q. So the factors of 5 are 1 and 5. Okay, if a rational solution exists, if this 4th degree figure does drop down and cross the x-axis, it will be in the form of P divided by Q. So our rational solutions here are going to be, let's see, how do we do this best? We usually start with the big guy. See, this is the only part of this stinking thing I did not practice, and so I'm not happy with it right now. Okay, we're just going to do it, but they're going to do it big to small. So let's start big to small. Let's go big number first. We'll work our way down the P's. So 10 over 1. That is not what I want to do. Okay, let's start here. Okay, hang on a second. Let me think for a second. Oh, okay. Welcome to Monday morning. 1 over 1. We're going to first do the first P over the first Q. So 1 over 1 is a 1, and we've got to consider both positive and negative, just because you do. It might be a positive 1, it might be a negative 1. Okay, now let's go 2 over 1. So that gives you a plus or minus 2. That could be the where this figure crosses the x-axis, if he does deign us to drop down low enough. Then 5 over 1, plus or minus 5. And finally, 10 over 1, plus or minus 10. Now we're going to go through and take the p's and put them over the 5. So 1/5, plus or minus 1/5. Then we're going to do 2/5, plus or minus 2/5. Then 5/5. Oh, we've already got 5/5. That's a plus or minus 1. And then 10/5. We've already got that. That reduces to plus or minus 2. So they're the possible rational solutions. Those are the numbers that can go in evenly. Those are all of the numbers right here. Now, obviously, what do we have? 2, 4, 6, 8, 10, 12. We have 12 different numbers there. We have a positive 1 and a negative 1. That's 2 of them, etc. All the way to positive 2/5, negative 2/5. So we have 12 answers. Only 4 of them are possibilities. We know that. That's the most this is going to cross the x-axis. If it crosses at all, it's only going to cross at 4 places. But we have limited the scope of our search down to just 12 numbers. Instead of looking for an infinite number of numbers. I mean, what might go into here? Oh, maybe a 3. Let's try a 3. No, 3 won't work. We would only be trying these numbers. If a rational solution exists, if this function drops down and crosses the x-axis, it will be in the form of P over Q. So when we get around to trying to figure out what numbers work up here, we're only going to be using these. That's our finite set of numbers from which we can choose. Okay, let's do another one. Let's do 5 of these before we even get into real division here. Let's look at f of x equals x cubed minus 3x squared minus 49x plus 147. Okay, if a rational solution exists, it'll be in the form of P over Q, where P are the factors of the constant, that's 147. So let's see, we're looking for the factors of 147 there. 1 times 147, you might need to do it that way because you don't know what works. I'll show you how we'll play that game. So you know that 1 times the number will work. You should be able to recognize that 2 won't go in there because that's not an even number. 3, you can test it, but you can also add the numbers up. 1 plus 4 gives you 5. 5 plus 7 gives you 12. 12 divides by 3. So 147 will divide by 3 and give us 49. So 3 times 49, those are possibilities for the constant. You know that 7 goes in there, so 7 is going to work, but you can try. 4 goes into 147. If 2 won't, then none of the even numbers will. 5 will not. 6 we can skip. 7. 147 divided by 7, and we get 21. So that is 7 times 21, and that's it. Those are all the numbers that are going to divide. How do you know that? You don't really, but if you go 7, you can skip all the evens. 9, you can try that. 147 divided by 9. Yeah, that's not going to work because it won't divide. 12 will not divide by 9. So we've got these, and you won't get these miserable urinary Olympics kind of ones. You'll get kinder than this, I promise. So we've got these factors of 147. Q will be the factors of the leading coefficient. Remember, Q is the factors of the LC of the leading coefficient, and that's just 1. So we know that the rational solutions for this problem, the only possibilities, the only numbers we need to test will be 1 over 1, that's a plus or minus 1, 3 over 1, 7 over 1, and you can see where we're going here, 21 over 1, plus or minus 49, and plus or minus 147. Q, being a 1, is the only denominator to test here. So it's just these whole numbers. So we have no fractions involved here. How many answers are possible? Only 3. And they come from this group. 2, 4, 6, 8, 10, 12. Again, we happen to have 12 factors there, and only 3 of them will work. We're not worried about which ones will work yet. All right, let's look at our third one. F of x equals 4x to the 4th minus x to the 3rd plus 6x squared minus 7x minus 34. Okay, just to make sure that you're thinking, how many possibles are there? There are 4 possibles. We're going to come up with, if we were going to solve this, we would come up with 4 roots, 4 zeros. Let's see, let's look at our p's. Let's figure out where these numbers are. They're only going to be factors of the constant, the constant. Let's see what those factors are. I know it's 1 and 34. I know 2 will go in 17 times. 3 won't, 4 won't, 5 won't, 6 won't, 7, 8, let's see, 9, 10. We're running out of numbers here. Once we hit half of it, we're done, and that's 17 anyway. So we're done. Those are the factors of 34. Q, the factors of 4, 1, 2, and 4. Okay, the rational solutions. The group of numbers, we're not going to look at infinite numbers. 5 will not be a number that will work. We can discount that one completely. We're only looking at the fractions made of P over Q. So we're going to look at plus or minus 1, then go 2 over 1, then go 17 over 1, then 34 over 1. Okay, now let's get everybody queued up with 2 on the bottom. 1 over 2, then 2 over 2. Well, we've already got that. That's a 1. Then 17 over 2. Then 34 over 2. And 34 over 2 reduces to 17, so we've already got it. Now let's take every one of the p's and put them over the 4. So plus or minus 1/4. Plus or minus 2/4. Well, that's a half, and we've already got it. Plus or minus 17/4, and then plus or minus 34 over 4, which will reduce to 17 over 2, and we've got it. So there's our possible list. These are what we would be doing synthetic division with. We would be trying out, we'd guess, and we're going to do that in a bit. And I'll help you with how to make those decisions when you're trying to guess 2, 4, 6, 8, 10, 12, 14, 16. 16 of these, there are 16 numbers in the world that are possible to work here, and we want to find the 4 that work. So you don't want to try all 12 wrong ones. And what will help you every single time, we're not killing you here. Don't try the fractions. When we start out to do synthetic division, we're not even going to bother with the fractions. They may work, but we'll find that out later when we factor. We're going to go after 1s and 2s, and the synthetic division, you know, is easy. So this searching, once we have this information and we start plugging in using synthetic division, it's not going to be grueling. Synthetic division's fun anyway. Okay, let's do number 4. Okay, I am going to go to the next page because we're actually going to work on synthetic division and finding the answers on these next 2 problems. We're doing the works here. Okay, let's look at f of x equals 7x to the 3rd. That's a 3. I'm getting a chair in a little bit, and my hubby is home, so when it comes to the door, he'll be able to get it, but it'll be a little noisy for just a minute. So sorry about that in advance. Okay, 7x to the 3rd minus 3x squared minus 175x plus 75. Okay, let's find all of our potential answers. We know it's going to be the factors of 75 over the factors of 7. So the factors of P of 75 are 1 and 75. 2 won't go in. 7 plus 5 is 12, so 3 will go in. and that's 3/4. 3 times 25. 5 will go in. If you're not sure, check it out. It'll go in 15 times. 6, no. 7, 8, 9, 10, 11, 12. No, we're done. There are factors of 75. Now let's look at the factors of 7. 1 and 7, that's it. So let's list our rational solutions. These are all the possibilities. We're going to only own 3 of them. Only 3 of the numbers we write here are going to work. We're only going to have to find 3. But the possible ones, all of the possible ones are built out of P's over Q's. So let's go through and use Q as a denominator first. 1 over 1, 3 over 1, 5 over 1, 15 over 1, 25, and 75. Okay, that's more numbers than we're ever going to test. We'll be able to find them pretty quickly. Now let's do all of these numbers over 7, because those are also possibilities. Plus or minus 1/7, plus or minus 3/7, plus or minus 5/7, etc. 15/7, 25/7, and 75, plus or minus 75/7. You won't be creating these in MyMathLab. They will give you a multiple choice. So they will give you this list or another slightly different list, that kind of thing. Okay. Let's now test them until we find. Now we're going to find. We're going to do this problem completely. We are going to test to find one of them, and then we're going to use our test answer to supply the rest of the zeros. So one of these, let's see, 2, 4, 6, 8, 10, 12, so 24. We have 24 answers here, and we're looking for the 1. It's like a needle in a haystack, but no worries, it's not so hard. Try 1. So let's put 1 in its little box, and then let's do 7, -3, -175, and 75, and do synthetic division. Multiply, we get a 4, multiply, ooh, this isn't going so good, -171, no, we want a 0 here, that's what indicates that it works. Let's try -1, again with the same numbers. So we get a -7, there's a -10, that's a +10. Now we're getting -165, this is not going to work. So this is a no, this is a no. So I'm going to cross out the 1s. We need something chunky here. We need to come up with a 75, and we're way too small. So let's bump, well, we got to bump up anyway. Let's bump up to 3. We are never going to try these. That's more work than you need. You'll be able to find an actual 0 amongst the smaller numbers, amongst the whole numbers. So let's try that. A good eraser would be helpful, and I'm doing pen so you can read it, so I'll just keep writing. 7 times 3 is 21. We're getting 18 there. I need 18 times 3 is 54. And then plus 175 gives me 121. Ooh, that's a mess. That's going to give me -363. That's not working. Let's try -3. You will see, because we're going to do many of these, that it usually doesn't take this long to find a 0. They come quick. -21, -24. This is looking good because this is going to bulk up here. So I got 3 times 24. That gives me 72, and it's a positive. It's not looking so good, is it? It's 103. That gives me 309. That is not a 0. Okay, 3s don't work. Let's try 5. Remember, what we're looking for is where does this guy, we know he's going to come from down there and go up there. Where does he cross the x-axis? Sorry. We know he's going to come from down there because he's the x to the 3rd and end there. That's his end behaviors. We're looking for where does he cross. That's what we're looking for. So let's try 5. $32. Okay. Got some hope here. Get 160. Oh, now we're going. Negative 15. Negative 15 times 5 is negative 75. So yay, we finally found him. Okay, so we know that 5 is one of our zeros. So if we're looking for our zeros, let me put it out here. 5 is a 0. Now, if they're looking for the factoring of it, you want to use x minus 5 because x minus 5 is the same thing as 5. Remember that when it shows up with the x, it's a liar. When it shows up on its own, it's telling the truth. So 5 is the 0 right here. It's probably doing something like that, coming out of there, coming out of there. Now that we've got this answer, let's use this to tell us what the rest of the equation looks like. This was x to the third, so our new equation is 7x squared plus 32x minus 15 equals 0. Remember, we have a 3 here, so our new information, this tells us it's a 7x squared. Okay, now we're going to be able to factor that. 7x and x, signs need to be different. How am I going to get 15? I'm going to use 5 times 3. So let's see, if I do a 5 there and a 3 there, I'll get an outside negative 35x and an inside plus 3x. That gives me a negative 32x. I want a positive 32x. So let me change that sign to a plus and that sign to a minus. Now we've got x equals, right here, we've got x plus 5 equals 0. So x equals negative 5. That's another one of our zeros. Right here, we've got 7x minus 3 equals 0. Move the 3 over and divide by 7, and you get 3/7. So we found 5 right there. We have these two also. So our zeros are 5, 3/7, and negative 5. And I'm going to, instead of doing it here, if they're asking you for the zeros, you give them the ones you got. Negative 5 and 3/7. Order doesn't matter. If they're asking you to factor it, you want to put it into x minus 5, x plus 5, and then I guess 7x minus 3 here. That's a little bit of a weird one. They would be asking you for the zeros in this one. But if they're asking you to factor it for the factors, that's what you would give them. Okay, let's play that game again. We started out with this. We came up with what were the possible roots. We tried them out till we found one that gave us a 0 for the remainder, and then used that equation, x squared, to factor, because we know how to factor. All right, let's look at f of x equals x to the third plus 8x squared plus 11x minus 20. Okay, we've got an x to the third. We know we're going to come up with 3 possible roots, 3 possibles. Let's look at the p and the q. The p is the constant, the factors of the constant. So 1 and 20, 2 and 10, 3 won't go in, 4 will. We end up with there. The factors of 1 are just 1. So our rational solutions, all the answers that are possible are each of these numbers, the factors of p over 1. Okay, 2, 4, 6, 8, 10, 12. We have 12 possibilities, and we're only going to get 3 of them out of that. But we know what our numbers are now. We know 7's not going to work. We know 2/3 isn't going to work. We know 1/2 won't work. We know only those will work. So let's try 1. 1, 8, 11, and negative 20. Times 1 is 1, gets me a 9, gets me 20. 1 times 20 is 20. Yay, we got a 0. That's what we want. So see, I was telling you, these are easier than this mess. We had to go 1, 1, 3, 3, 5. So 1 worked. So when I'm looking for zeros here, 1 is a 0. We got one of our answers. We need 2 more. And what we're going to do is we're going to use this to find the other 2. That was x to the third power, so we're going x squared plus 9x plus 20 equals 0 to solve the rest of this. X and x, plus and plus, Two numbers that multiply to give you 20 that add together to give you 9. It's 4 and 5. Solve each one of these. So x equals a -4, x equals a -5. So if you're looking for zeros, they're the zeros. If they ask you to factor this, they're looking for you to factor it, then you've got x minus 1. That's the first one. This is a positive one, but when you attach them to an x, you make them a liar. And then we're going to have to put, well, this -4 becomes x plus 4 because there it is right there, factored. If it's beside an x, it's a liar, and x plus 5. So if they're asking you to factor it, put it with x's and change the sign. They're asking for the zeros. There you go. And notice that 1 is, there we go, rational solutions. 1 is one of them, -4 is one of them, and -5 is one of them. So they will come from that list that we create there. Okay, let's see, let's go to the next thing. Okay, the next thing is sort of this odd little thing. How many of them will be negative? How many of them will be positive? That's what's happening next, is how do we know what the signs of these will be? I'm not sure that's particularly useful, but my math lab thinks it's particularly useful. So we'll play the game. So what we're doing here is sign changes. Sign changes tell you how many real roots, how many of the roots will be real, how many real roots, how many times it will cross the x-axis. Let me grab something I was talking to you about earlier. Here we go. Real roots are where they cross the x-axis. These are roots, but they're not real. They're unreal. They involve I because they don't cross the x-axis. So what we're looking for is how many of them will be real. How many, let's figure out how many times it will actually cross the x-axis. So what happens here is if there is one sign change, and this is one of your my math lab problems, if there is one sign change in the problem, that indicates you have one real root. Everything else is a little funky. To find the, let's see, I don't know which way to go with you here. Multiple sign, okay. If we're looking at f of x, if we're looking at the equation itself, just staring at the equation that they give us, then the sign changes tell us how many positive real roots we have. The sign changes will tell us how many positive real roots we have. If you plug in f of -x, the sign changes tell you how many negative real roots you have. So the same stuff, sign changes, and we're going to look at this. I know right now you're like, no, don't get that, but you will. We're going to do 3 of these to come up with how many sign changes there are and what does that tell us about positive real roots and negative real roots. So sign changes will tell us how many negative real roots there are. And then for both of these categories, you know what, I'm going to save that. I'm going to save that till we actually do it. There's something funky that goes on there. Let's look at 3 of them. Let's look at f of x equals x cubed plus 3x squared plus 4x plus 1. Okay, let's find out how many of these might be real. We're told that by the sign changes. When you're looking at the equation itself, that's what this is, f of x. Let's look at how many sign changes we have. Positive, 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 positive. 0 sign changes. So there will be no positive real roots here. It will not cross the x-axis over here. That's just not going to happen. Now let's look at f of -x of this same equation. We're going to take each one of these x's and plug in a -x. So -x to the third will give us -x. Negative x, if you plug it in there, you'll get a positive. So this will still be positive. If you plug in a negative x there, you'll get negative 4x, and then plus 1 won't be affected. Okay, now let's look at sign changes. That's a negative. Oop, there's a sign change. 1. Oop, there's another sign change. See, it went from negative to positive to negative to positive. So how many changes was that? No change there, no change till we move. We're like a froggy. Until we move to the next lily pad, nothing happens. So we've got 1 sign change, 2 sign changes, 3 sign changes. So that tells us that we will have 3 negative roots, real roots, or 1. And this is the thing that's funky. Let me explain this part first, and then I'll get to that one. When we plug in a negative x, we then compute for that negative x, and we're looking for sign changes. That will tell us how many negative real roots we might have, how many times it's going to cross the x-axis over on the negative side. Well, we found 1 sign change from negative to positive, 2, 3. So there are 3 times that it will do that. Or 1. We're going to subtract 2 every time. So it will happen either 3 times or 1 time over here. It has to happen 3 times or 1 time. We won't have any positive real roots. It'll never cross over here. It's only going to cross over here, and it will only cross 3 times on the x-axis or 1. That's all. When we have a number here, you're always going to subtract 2 to find the other possible numbers. They come in the same number or less by even integers, so by 2s. So that if we had 7 changes that we occurred here, it'd be 7 or 5 or 3 or 1. If we had 6 sign changes here, it'd be 6 or 4 or 2 or none. Okay, that's one problem right there. Let's do the same game for another one. Let's look at f of x equals negative x to the 5th plus x to the 4th minus x to the 3rd plus x squared minus x minus 5. Okay, because we're looking at positive x, we're looking at sign changes will tell us how many positive real roots, how many times over here our figure, our function, will cross the x-axis. So let's look at sign changes. We've got 1 sign change. Remember, you're concentrating on the sign in front. Negative, positive, negative, positive, negative, negative. So how many times does that change? 1 change, 2, 3, 4, only 4. So this tells us we will have 4 or 2 positive real roots. Going to have 4 or 2. Won't go down to 0. 4 or 2 positive real roots. So that means this figure is going to cross the x-axis over on this side, in the positive side of x, 4 times or 2 times. Now let's see how many times we're going to have negative roots. Let's plug in a negative x into this. Okay, this is going to get to be messy. If we plug in negative x to a 5th, that's going to keep its negativity, but it's got a minus in front. So this will be an x to the 5th. If you plug in a negative x and raise it to the 4th power, it's still going to be positive. Ignore the negative. If you plug in a negative x to the 3rd power, negative x raised to the 3rd will give you a negative, and it's got a negative in front of it. Negative x squared will give us a positive x squared. Minus a negative x will give us a positive x. And then we've got a negative 5 on the end. Okay, when we're working with negative x, it's the same thing. Sign changes tell us, except they'll change us how many negative real roots we have. How many are happening over here? So how many sign changes do we have? Goes from positive to negative right there. So we will have 1 negative real root happening here. That means it's going to cross 1 time over here, and 4 times or 2 times over on the right-hand side in the positive real root section. We only need 5 of them. So if it crosses 1 on this side, it ought to cross 4 times over there. Although some of them could be up in the air and not crossing at all. Let's look at our last one here of detecting the sign changes. By the way, this is called Descartes' rule of signs. That kind of matters. They refer to that a lot in my math lab. Descartes' rule of signs. This dude named Mr. Descartes, French guy, he made up this rule that if we look at the sign changes, we can tell how many times it's going to cross the x-axis on the positive side or on the negative side if we change the x's to negative x's. And then that will reduce by 2. It'll be that same number or less by even integers of 2. Okay, let's look at one last one here on Descartes. F of x, the normal equation, is negative 2x to the third power plus 5x squared minus 6x plus 2. Okay. So as it happens, we're looking at f of x to detect how many sign changes will be positive. So let's look at how many of those. We got a 1, we got a 2, we got a 3. So we know we're going to have 3 positive real roots or 1. It's got to go down by 2's. So it'll either cross the x-axis on the positive side 3 times or only once. And then let's look at f of negative x to see how many times it's going to cross over here on the negative side of the x-axis. Let's see, if we put in a negative x there, negative x to the third power gives you a negative x. It retains its negative. Negative times negative is a positive. If we put in a negative x right there, we'll make that positive. If we put in a negative x right there, that'll make that a plus 6x. And then we've got a plus 2. Okay, so we're looking for sign changes here. There are no sign changes here, so there will be no negative real roots. That's not happening. It's not going to cross the x-axis over here. Let's look at that original equation. It's an x to the third, so we know that it's going to start down. Oh, but it's negative, so its end behavior is starting up here, ending down there. And remember, we're looking at f of x, this one. It's got to cross 3 positive real roots or 1. So it's going to change in here like that. It's going to do that. 1, 2, 3 positive real roots, no negative real roots. It won't cross on the negative side at all. That's what that tells us. Mr. Descartes figured that out. Okay. Yeah, we did that. Okay. And then I did want to graph by end behavior only on these. So we've done this third one. That's the third one. This guy right here, this first one that we did, the first one with the little star by it, that's an x to the third. So we know his end behavior goes down there, up there. No positive real roots. So we're not over here at all. 3 negative roots or 1. So it's probably going to do something like that. And that won't curve that crazy. It'll be smoother than that. But 1, 2, 3 negative roots like that. This one right here, the second one that we did, is an x to the fifth, but he's a negative, so he'll start up there, come down there. We will have 4 or 2 positive real roots. So 4 times over here, or just twice, once over here. So if they're all real roots, and let's assume that they are, then it's going to do 1 time on the negative side, like that. It'll cross there once. And then it's going to do some squiggly stuff here, but 2, 3, you know, that kind of thing, and then go back down. 1, 2, 3, 4, 5. So we have our 5 in there, and then 1 of them is negative, 4 of them are positive. Okay, here's the good news on all of this. You've got some homework to do on that, but it just doesn't carry over into anything else that we do, so it won't be on the test and it won't be on the final. None of that Descartes' rule of signs will be. It's good work for your brain, especially when you're plugging in a negative x into these things. Okay, let's move forward. Let's look at find the polynomial with these characteristics. This will be on the test. This will be on the final. Okay, find the polynomial with these characteristics. We're going to do 2 of these, and then we're done. We are done with this section. So we've got n equals 3. That means that we've got 3 times it'll cross the x-axis. It's a 3rd degree polynomial. So we know we're going to have 3 roots. 1 and 3i are zeros. Okay, we've not dealt with I because that just means it's not crossing. I mentioned it to you. This sort of thing will have I roots because it doesn't have, it's crossing, it's an x squared. You know it's a polynomial, it's going to have an x squared, but its real roots will be i's. They're imaginary. They're not crossing the x-axis. So they'll be i's, and that's the kind of thing we're looking at here. Probably with this, it'd look like that. It'll cross the x-axis once, and that's it. The other times are imaginary. Hang on a second. 7 minutes for the chair. Okay. Got my guy on that. Okay, f of -2 equals 117. Okay, we're going to do some math on these 3 facts, and this is a process that is different from what we've done. This is the algebra of what we've been looking at. Right here, we've been looking at the graphing of it, the decisions about it. Now we're going to put it into algebra. This is super simple. Nothing in here that you don't know. It's just a little bit weird looking. So let's start with f of x equals, and then leave yourself some room here. I'm going to tell you what to put here in a minute. But we know we need 3 sets of parentheses. N equals 3, so set up 3 sets of parentheses. Now, what are the roots? They tell us right here. 1 is one of them. So you know that's going to be x minus 1. 3i is one of them. So you know that's going to be x minus 3i. Because remember, when it's accompanied by the x, it's a liar. And now here's something you don't know. When you've got an imaginary guy, you're also going to have his conjugate pair. So we're also going to have x plus 3i. That doesn't occur with real crossings. It does occur with imaginary crossings. So they'll give you all of the information you need, x minus 1, x minus 3i, but you have to know that if you've got an I involved, you'll also have his conjugate pair. Change the sign. Okay, now, there might be a constant in front, like we had a 2 right there. This is the place that would appear. So I'm going to put an a right there. They write a sub n when you look at view an example, but it's going to be our number, and we'll worry about it. That'll be our last thing to worry about. Okay, let's start working this out. Let's start multiplying this out to find the polynomial. So f of x equals, keep a there. I'm going to FOIL x minus 3i times x plus 3i. Let me do that over here for you. X minus 3i times x plus 3i. Let's FOIL it. X times x is x squared. This is a conjugate pair, so outside and inside cancel out. I'm going to write it here one time so you can see it. Outside is a plus 3ix. Inside is a minus 3ix, and those will cancel. And then we've got the last. A negative times a positive is a negative. 3 times 3 is 9. I times I is I squared, and your brain needs to go, oh, I squared, and maybe you haven't done enough I's to have your brain do this, but I squared equals -1. So I'm going to cancel out this I squared and put a -1 and multiply. So I get x squared, -9 times -1 is plus 9. And there we go. That's what we get when we FOIL out the i's. We'll do the i's again in a minute. We'll have another opportunity to FOIL out conjugate pair i's. But it's pretty simple. I mean, if we did 5 of these, you'd pick up the pattern really quickly. It's going to be x squared plus instead of minus, because the i's will make it the opposite sign, and then 3 times 3 is 9. It's not super fancy. So that goes right here, x squared plus 9. Now let's take the next step and FOIL these. You want to do this in order, and if you can't get the order right off the bat, you can work on it. So you want these in order. I want the highest order first. X times x squared is x to the third. That's the first of the FOILing, F-O-I-L. Now I want the squared term. I want -1 times x squared. I want these in descending order here, so I'm going to be picky about the order. It's not going to be the outside is next, because that's the x term. I'm going to get the inside next. I want the x squared because I got x third first. So minus x squared. Then I want the x term. That's x times 9. And then I want the number. So minus 9. There, I've got it in descending order. If you FOIL it out and you get it in a mixed up order, no problem. Just take another line to get them in the correct order. Okay. Now what we know is that f of -2 equals 117. We're going to use that fact to find a. So let me show you what we're going to do. We're going to do f of -2 equals a times x to the third minus x squared plus 9x minus 9. Now here's a thing that you're not used to doing. We know that f of -2 and 117 are the same, so substitute 117 right there. Keep the a. F of -2 and 117 are identical. We find that out right there. Now let's go through here and put in a -2. -2 to the third power, that's -8. -2 squared is a +4. That'll be a -4 there because it's got a minus sign in front. 9 times -2 is -18, and then minus a 9. -8, -4, that gives you -12. -12 minus 18 gives you -30. -30 minus 9 gives you -39. Keep solving for a. So we're going to divide by -39. We get a equals -3. Yeah, that'll be a 3. Let me just make sure. 117 divided by 3 is 39. Good. Okay. So there's our A. There's our A. All the way down here, we know that our front number is a -3, like this was a 2. So let's get this ready for my math lab. Where they want it, they want you to put the -3 right up here and distribute it. So they want f of x equals -3x to the third power. -3 times -x squared is a +3x squared. -3 times 9x. And -3 times -9. That's what they're looking for right there. Okay, let's look at how we did this, and then we'll do one more. Here's the information they gave you. They told you the degree was 3, so we set up 3 sets of parentheses. They told us the roots. 1 was a root, so x minus 1, you know it needs to be a liar when it's being factored. 3i, so x minus 3i. And if ever you've got an I, you've got his conjugate pair. Now let's start building this guy up. So FOIL these out, and we got x squared plus 9. FOIL these out, and we got this. We got our train, x cubed, blah, blah, blah. Then what we're going to do is we're going to use this f of -2 equals 117 to plug in -2's here and set it equal to 117 and figure out what a is. A is a -3, and you'll get a nice fat plump whole number there. If you get anything else, you did something wrong in there. Then to get the answer, they want it strung out with the -3 distributed. Okay, let's go do one very similar to that. Let's say that n equals 3 again. 2 and 2i are the zeros here. And f of 1 equals -10. Okay. I would invite you to use the previous problem as your model and work on this. See what you can do about solving it. I'm going to give you about 3 minutes to solve it on your own or to get forward. And I know some of you are not taking notes because you are paying attention and then you go back and take notes. So let me pull this out here and put it so you can see it. Those of you who are not writing notes. So you can use it as a model. Okay, so there's the other one. See what you can do about making this work for you. Let me give you 8:55. I'll come back at maybe 9 o'clock. I'll give you a good solid 4 or 5 minutes. Okay, let's look at this problem. Anybody want to offer what they got for A, what they got for their number to multiply, their A guy? Good, good, Amanda. Yeah, 2 is what you should have gotten. If you didn't, I mean, do not feel like, you know, if this was lost on you, that's okay too. This is the second one we've done. They're not difficult. You will see that, but there are many steps, there are multiple steps. So let's see what we're going to do. Let's do this very structured so that you can replicate this later. So n equals 3 tells me that I need to have 3 sets of parentheses. I know I'm going to have 3 roots. Now, I'm going to go ahead and put in my little a here to remind myself that this piece right here is going to give me that 2 that we're going to put in there eventually. Okay, we need to put in our x's. This is always going to be x's here. We've got a 2. It's a positive number, so you want to put in x minus 2. We've got 2i. That's a positive number, so you want to put in x minus 2i. And anytime you've got a non-real number, you're going to have its conjugate also. So x plus 2i. Okay, let's keep moving. F of x equals, I'm going to FOIL those 2 out. So x minus 2i times x plus 2i. If you like shortcuts, this is easy to shortcut. If we're going to FOIL it, x times x gives us x squared. Outside is 2i, inside's minus 2ix. Inside's minus 2ix, those cancel out. And then the last, it's a negative times a positive is a negative. 2 times 2 is 4. I times I is I squared. Always, I squared gets canceled out and becomes a negative 1. Negative 4 times negative 1 creates x squared plus 4 for this bit. X squared plus 4. Let me rewrite all the rest of the gobbledygook. So we got f of x equals, keep your a. We're going to FOIL these out, and I want to put them in descending order. So the first will give me x to the third. Then I'm hunting around looking for what will give me x squared. There's x squared times a number. That'll do it. Then I'm hunting around for x. There's an x times a number. That'll give me 4x. And then finally the number, just 2 numbers multiplied together. Close that parentheses. Now's the time to use this idea that if we plug in a 1 here, we're going to get a negative 10 there. So negative 10 equals, and then let's plug in 1. 1 to the third power is 1. 1 squared is 1 times negative 2. 1 times 4, and then a minus 8. Neat this up a little bit. 1 minus 2 is negative 1. Negative 1 plus 4 is 3. And 3 minus 8 is a negative 5. Divide both sides by negative 5, and we get a equals 2. So my math lab wants this polynomial of yours to be that level right there, but with the distributed 2. So f of x equals 2x to the third power. Well, here, let me do a better job of that. F of x equals, put the 2 out there, and then x to the third minus 2x squared plus 4x minus 8. They want you to actually distribute. So 2x to the third minus 4x squared plus 8x minus 16. And you'll have one very much like these. We'll do it on the review. You'll see it on the review on my math lab. And we will do it on the test. Actually, when I say we, I mean you. We'll do it on the test. Okay, we are ending up a little bit early today. That's nice. Nice treat that you don't get. Although if you love algebra, that's sort of sad. Let's see. We got 3.4. We're done with that. And I know some of you may be still copying this. So 3.4 is done. Wednesday we'll review. Let's see. I've got the review pulled up on the slide, on the Google slide. So it looks like this. It's a couple pages long. I'm going to change one of them. In fact, I'm going to change the one we just did, the I problem we just did. Answers are all there for you. It's 3 pages. You don't have to print it out. I will do each one of the problems for you on Wednesday. And then you'll have Wednesday, Thursday, Friday to take the test. Questions? What's on your mind? Okay, that was me giving a long time because otherwise people won't ask questions. And it sounds like you guys don't have any. So I will see you on Wednesday. I'll stick around if you have something you want to talk about. I'll leave last. So see you on Wednesday.